Hello everyone and welcome to Llama Cyber or Why Cyber. The podcast where we explore the stories, the people and the breakthroughs shaping the world of cybersecurity. I'm Danit Leybovich-Shati. I'm a lawyer, an investigator and a tech enthusiast. And this week I have a very special guest, Esti Peshin. Esti Peshin is the Vice President and General Manager of the Cyber Division in IAI. It's the Israel Aerospace Industries. She is also an enthusiastic pilot and a CFI, a Certified Flight Instructor. And why is that important? Let Esti explain. Welcome.
Thank you so much, Danit. It's great to be here. It's great to be part of this podcast. I think that when we're speaking about aviation, it's becoming more and more important to incorporate cybersecurity into the aviation life cycle, starting from the manufacturing of the planes in a cybersecure manner and through the operation of the planes and the entire aviation ecosystem in a cybersecure manner.
Even the airports.
Even the airports. This is part of the
everywhere.
ecosystem. It's
the towers and the baggage rails, and it's everywhere because everything is getting digital, right?
Exactly. So basically, we have three elements that are governing why cybersecurity is so important in aviation and practically in any other critical element of our lives. Number one, connectivity. Everything is becoming more and more connected. So today, you can, as a passenger, you can basically do everything you need to do regarding a flight online, on the internet.
Yeah, check-in and payments.
Check-in and payments and checking the status of your flight. And you can actually see where the plane is at this specific moment and when it's going to arrive at the airport. And then the airplanes are connected to the air traffic control. They're connected to various information systems, allowing the pilot to kind of understand where they're at during the flight. The pilots have an EFB, an electronic flight bag, which is essentially an iPad that includes a lot of information about the flight, like the flight plan, various airports, etc. So everything is interconnected. And when we're talking about connectivity, we're talking about an increased, a heightened attack surface.
Yeah, in cybersecurity, where everything is digital, it's all a threat and vulnerable.
Exactly.
And it can all be messed up.
Exactly. So connectivity increases, attack surface increases. And when we're talking about the aviation sector, we're talking about a huge impact. Consider, for example...
You also need it to be always online and on real time because you don't have time to wait for the computer to restart.
Exactly. So during the flight, we're speaking about a flying data center that is 30 or 40,000 feet above the ground. So this is a huge impact.
Yeah.
It better be cyber secure. But even when the plane is on the ground and we are now preparing for a flight, essentially each and every one of us has a slight fear of flying. We don't feel that comfortable at 30 or 40,000 feet in there, right?
Sitting in a can.
So every anomaly relating to aviation is something that impacts us. For example, if there is a cyber attack or maybe just a malfunction and the check-in systems at a certain airport are now down and the passengers are waiting and there are more and more passengers and they're sitting on the floor. So this will be a huge news item.
Yeah, and they have connection flights and everything. Well, you're a pilot, so now it makes sense to discuss the aviation cybersecurity surface. But everything is scheduled to the minute, right?
Correct.
If there's some kind of delay, then it can ruin everything.
There's an effect, a ripple effect that will impact passengers all around the world because aviation works in slots. So they have landing slots and now they're missing the slots. So they need new slots and the passengers are waiting and they're missing their connecting flights. So it becomes a small chaos. Yeah. So this would be a huge news item.
Chaoses. It wasn't a cybersecurity issue, but the world did experience a malfunction with the CrowdStrike application that halted the check-in process in some airports.
Yes, and there was, you're speaking about a technological one, but, weather sometimes impacts as well. When there was
But you don't have anyone to blame when it comes to weather.
Oh, you can always blame someone. You can always blame someone. There's always someone to blame. But, for example, when there was a volcano eruption in Europe, and then all the flights in Europe were grounded, it created a chaos that lasted, revealing the chaos took a few days. So, to summarize this point, increased connectivity, larger attack surface, and high impact. These are the reasons why aviation needs to be cyber secure.
Because we get security in aviation. Well, every time we board a plane, we know that there are security checks and they're checking our bags and so on. That we understand. But the digital surface behind all this is something that I'm not sure all passengers know. And I am sure that even from what I feel I know, it's not everything.
Yeah, so let's speak about 5 features of aviation that are, in a sense, unique or somewhat unique to the aviation sector. So first one is, when you consider a network, and you're a cyber expert, right? So there's a network, and there are endpoints in the network, and there are servers in the network. So when we are talking about aviation, we can consider the airplane, like an endpoint. But the difference here is that the airplane needs to be able to land at different airports. So it's like you taking your computer and connecting it each and every day to different networks that are not under your control.
And they are different, not by name, like we connect to Wi-Fi, it's the same Wi-Fi everywhere. It's different by its technology, right? It's not always the same.
It's not always the same technology, but the main issue here is that these airports are secured by different CISOs. You're a cybersecurity expert. Would you connect your laptop to an unknown network secured by a certain CISO that you do not know in a different country?
Now I'm ashamed to answer the truth.
You probably wouldn't do that, knowing you.
No, of course not. Never. I've never connected to an open Wi-Fi network.
Good.
Can I speak the truth now?
No. Let's keep it this way. But consider the airport. It's not just your laptop. The airplane is essentially a critical infrastructure. It's an end-to-end critical infrastructure that is now connecting to an airport in a different country and uploading data and downloading data. So this is one aspect of aviation that needs to be considered.
It's actually connects. It's not just landing and waiting for further instructions. The airplane actually connects to the infrastructure of the airport, of the airport's network.
In some cases, the answer is yes. In some cases, some airlines avoid this connectivity.
Because of what we talked about.
Because
it
of what we
secure
talked about, yes.
And we are not familiar with the technology and so with the security aspects of the network. But so that means they don't have to, or they don't must connect to the local network.
Yeah. So as aviation moves forward and becomes more digital and more reliant on information systems, then eventually everyone will have to connect one way or another. But at this point of time, it's still not
necessary,
not completely mandatory in every airport. But there are networks to which an aircraft must connect. For example, air traffic management network.
Yeah.
So again, we are communicating with networks, and we have a high interdependency on these networks. They depend on information from us, and we are depending on information from them. So again, the criticality of the ecosystem becomes very much apparent. We have another aspect that is worthwhile to mention, and this is automation. In commercial aviation, planes fly a lot of the time on autopilot. This is automation. Automation means software, means computers, means something that essentially may have its flaws. may have its flaws. So this is something that needs to be considered. And today, the aviation industry is transitioning towards more dependency on automation. The automation makes more decisions for the pilot. And there are even discussions about SPO. This is single pilot operation, where there will be one pilot in the cockpit, and he will be supported by communication from the ground.
So AI is taking the pilot's job.
I doubt anyone will ever take the pilot's job, but AI is increasingly assisting the pilots in making informed decisions.
I have a question that really intrigues me now that we're discussing on that technology. The towers are occupied by personnel equipped and professional personnel that manage the traffic of the airplanes. And will they be replaced by technology? Because it's so delicate with real-time decision making and looking at the bigger picture, and it's a safety issue. And I know there are strict rules for professionals in towers. Will they eventually be replaced?
I don't know. The bottom line is, you can't predict. If anyone would have been asked 5 years ago, how will technology look now in 2025? I don't think he would have given a realistic answer. So I wouldn't.
So you say
I wouldn't presume to assume.
So we have 5 years. You say.
I don't presume to assume that I know anything about the future. But what I can say is that information systems and AI systems, artificial intelligence systems, and machine learning systems are becoming very important in assisting decision making. And this is a trend that I believe will grow. Will they eventually replace the professionals involved in aviation? I don't know.
If I
had to bet, I would say no.
Because we are too conservative, or because we are better? Because I think that today we are starting to understand, and not just hear about, but actually understand that AI and computers, they are better than us in many ways. But we do have our special, unique, humanized magic that can't be replaced. When thinking to myself, I'm not sure where that magic will stay, except for, I don't know, gardening or...
Well, I think that we have some advantages over computers in our ability to consider moral aspects in a manner that is empathic. And when pilots or controllers are making decisions that may impact the lives of the passengers, I would prefer that they have this moral trait.
In human decision making, because I understand what you're saying. It's just a debate in my head, and you're helping, so thank you.
Happy to assist.
Because we sometimes, as humans, we make decisions that are not, that their outcome is not probable. But we do want to save everyone, so we'll choose the less probable solution instead of it more likely that we'll save two passengers if we land to the right, and we might save all of them if we land to the left, but the odds for that is 2%. So I think that humans will, maybe you're better than this and I, may choose to save everyone, even if the chances are lower than saving some with better chances, no?
Well, it's a bit too philosophical for me, but I can say that our advantage over the computers is that we incorporate morality and empathy into our decision making. And I don't know, how things will evolve. Maybe machines will grow some form of morality or empathy. Maybe they will learn how we as humans make decisions. But, This is not for me to predict.
But thank you for participating in this debate in my head.
I'm always happy to assist any debate in your head. But just to conclude this point, aviation is a strategic target, and it has characteristics that are, I'm going to say, relatively unique in terms of the complexity of the ecosystem, in terms of the dependency on computers and on automation, which is becoming increasingly more and more apparent.
And there are different types of computers and technology in the aviation, I don't know, scope of technology, because I don't know, but I'm not sure that every manufacturer uses the same technology as others. From what I know from healthcare, the healthcare industry, each product is completely different. They build their own operation systems. They build their own protections and processes of actions. And if I'm taking what I know here to what I don't know in the aviation, I'm asking you, is it the same? Or they have strict rules to use the same basic technology?
So, like in every tech ecosystem, there's a diversity of technologies. So, if you're talking about the functionality, then the functionality is similar, but the way it's implemented may be different. And in aviation, like in any other OT-based ecosystem, then there are a lot of proprietary protocols or unique protocols, and there's a combination between IT and OT, and even the ways the airplanes are implemented are different from one manufacturer to another, and the airplanes incorporate technologies from various vendors or OEMs. So yeah, there's a huge diversity here. And this is why regulation has to take a stand on this to ensure that cybersecurity is implemented throughout the entire development and operation lifecycle of an airplane. So it's critical. It's critical for us.
Is there enough regulation? Because aviation is a very regulated domain.
Yes, so it's a very regulated domain, but not in cybersecurity. So the regulators, especially EASA, the European regulator, and FAA, the American regulator, are stepping up and increasing the cybersecurity regulation, and are now insisting on increased cybersecurity awareness and increased cybersecurity as part of the development and operation lifecycle. So EASA actually implemented a Part IS regulation that is going to take effect in October 2025 for some of the initial elements in the ecosystem. They basically require improved risk management. They require improved event management. And speaking to you as a researcher and an investigator, they require what they refer to as constant improvement. Meaning that if an event has happened, then they expect the operator or the system owner to actually investigate it, to understand what happened, and to implement the proper countermeasures looking forward.
And make this the needed changes. They want constant improvement. Because what we know from cybersecurity, that you can't be fully protected. There's always something that can get to you.
Yes.
So I understand why they want everyone to keep progressing, but it's very tough for regulation to predict the future, and to guide the industry. So I understand it's a first step, but there's a lot need to be done. Do you think they should guide, or are they guiding the future of technology, how to use decision making, or how to use interconnectability and so on?
Well, I would say that they're looking at it, but regulation basically isn't isn't providing guidance. They're basically providing a
reaction. They react to
the necessary. I would say I would use the word controls, and their controls are relatively generic, so they would apply also for future technologies. So you need your risk assessment regardless of what types of technologies, what type of automation, of what type of code practices you use on board the airplane, or use in the airport, or use as part of the manufacturing process. So they're basically creating these kind of controls or guidelines. The challenge here is that the aviation industry is a very conservative, and they exist for a very long time. So
if it works, don't touch it.
Yeah, essentially, this is the essence. So it's difficult for them to adapt, but they are doing that, and the regulators are aiding in this. And this is also a great opportunity for tech companies to create enabling technologies. So just to give you one example, Aviation, a startup company that was established by IAI together with additional investors, is focusing on enabling technologies that allows to perform risk management on actual airplanes. And this is compliant with the EASA regulation. So this is something a lot of airlines are looking at today, to incorporate this technology as an enabling technologies to allow themselves to comply with the regulation.
Yeah, so the regulators are initiating their first steps of regulating the technology and cybersecurity aspects, and there are solutions to help comply with that.
Correct.
And then the industry will be able to move forward and expand the cybersecurity aspects of the aviation industry.
Yeah, so what you said is correct, except that it is already an ongoing process. So EASA already implemented the regulation, and it's kicking in October 2025, which is just around the corner.
Yeah, in my head it's in the past, but
okay, that's fine. And the FAA already issued what they refer to as an NPRM, a notice of proposed rulemaking. In August 2024, they received the comments from the public, and they are now legislating their cybersecurity regulation, which will focus again on risk management and the entire life cycle, the entire manufacturing and operational process. So things are already underway, which is, I think, a very good thing.
Nice. And we don't have a lot of time to conclude this episode.
I could have spoken to you for hours.
Yeah, me too. And now I'm looking at at the clock, and we should move forward, because we wanted to talk not only on aviation but also on transportation. Do you see the threats? Do you see if the threats are similar in sea, land, and air transportation?
Yeah, so the threats are relatively similar, but the implementation and the regulation differ, and so do the risks. So when we're talking about an airplane, we're talking about an element, for lack of a better word, or vehicle that is 30 or 40,000 feet in the air.
Yeah.
But when we're talking about land transportation, when we're talking about maritime vessels, then in both cases, they're critical infrastructures. They utilize automation. Today, we have the connected cars. We have the autonomous cars. The cars are becoming more and more autonomous. They have more driver aid capabilities. In most of these elements, there's some sort of remote access. They are receiving information from the outside, and they're transmitting information to the outside. There's real-time communication. The systems are complex, incorporate proprietary protocols. There are OT components. There is a concern of data manipulation, because they depend on data for their navigation, for their decision-making. And in all these industries, the awareness is lower. It's not, the software industry where we grew up with an understanding of the cyber.
Secure by design.
Well, initially it wasn't that by design, but, we grew with an awareness. But in the automotive industry or in the shipping industry, they had to learn cyber. Mm-hmm. So the threats are similar. But in terms of how these threats are come to life or how they're handled or the risks, it's a bit different. So, for example, in the maritime, we have a ship. The ship has a crew. The ship is connected to a shipping company. The ship is part of a critical infrastructure. They are transferring goods from country to country. So navigation, for example, can be disrupted. It can happen also to planes in the air. It can happen also to cars that are driving or to public transportation. But the risk to human life is lower. So navigation is out. There are options. There are things that can be done. We are not 30,000 or 40,000 feet in the air.
It's not an instant effect. In maritime, if the ship will turn to the wrong way, it may take time until you see the the island, but you will be able to turn it back. It might cost in terms of time and travel and so on, but it's not as immediate like in airplanes.
Yes, and exactly. And when we're talking about land transportation, so, we can speak about public transportation like trains and buses that in many cases are governed by IT systems or OT systems for the signaling, for example, in trains. And we can speak about the connected car. Your car probably has some information system already incorporated within and some driver aiding systems. Yeah. For example, the emergency braking system, which is computerized.
Yeah, and lane keeping and distance
and distance, the autonomous cruise control.
Yeah.
And all these systems can be disrupted and can essentially risk your life.
Yeah, and they will be eventually connected to traffic lights and the streets.
Some of them are already connected to the traffic lights in certain countries.
And speed limits.
They're already interconnectivity. They're already V2X networks. And in Israel, some of these...
X is everything?
X is everything.
Vehicle to everything.
Vehicle to the world.
Yeah.
and here, I think it's important to mention that I established, together with the Israeli National Cyber Directorate and the Ministry of Transportation, through Ayalon Highways, the government-owned company, a cybersecurity lab for smart mobility, for smart transportation. It's called CYTS, CYITS. It resides in Beersheba, and it creates a lot of value in terms of cybersecurity for smart mobility, in terms of training, intelligence services, cyber threat intelligence services.
Do you predict that this collaboration and these initiatives, can we talk about a digital Iron Dome for transportation?
Oh, I'll start by saying I wish. The idea is very appealing. A holistic system that will be able to monitor and detect and prevent and respond to threats.
And add the human touch.
And then the human touch, right? But in reality, there's no single magic solution. And I think what we need in transportation, like in any other type of complex network, is a multi-layered architecture that will combine sensors and AI for better decision-making and for better detection, and human teams, and a centralized monitoring of the entire ecosystem, the ability to respond operationally quickly. So in order to be able to protect an ecosystem, we need 6 elements. First, we need early detection, both at the component, the plane, the car, the train, or the infrastructure level.
Like a vulnerability assessment, or if something is wrong, like a SIMSOC, you get an alert, well, something unusual is happening.
So both. In terms of cyber threat intelligence, you know that someone plans to attack you. In terms of detecting anomalies that may indicate a cyber attack is impending. In terms of detecting indicative signals that something is happening, you don't really know what, but you understand that this may be related to cybersecurity, may be related to a cybersecurity attack. Someone tried to enter your computer and entered the wrong password 3 times. This probably indicates that something is going to happen. You need risk management, and this refers also to vulnerability assessment. You need the ability to assess the threats. Are they applicable to me? What should I do in order to mitigate them, in order to prevent them? You need investigation capabilities. Something happened. How does it impact my system? What should I do to remediate this? What should I do in order to implement countermeasures so it won't happen again for me or for other elements within the ecosystem? You need information sharing. And if there's one thing I stress every time, is that information sharing is king. Because if a certain airline is targeted and cyber attacked, and this airline would share the information with other airlines, the other airlines will be able to protect themselves. And next time, it will be a different airline. So our strength lies in our numbers, in our ability to collaborate. And finally, and this may be, again, a very important one, training, awareness, making sure that everyone throughout the entire ecosystem is aware of potential cyber attacks, identifies anomalies, reports these anomalies, and acts upon them. And this would create a more secure ecosystem. So it may not be an iron dome, but it will improve cybersecurity for the aviation and for the transportation sectors.
Esti Peshin, you are fascinating.
Thank you so much.
And thank you so much for joining me on this episode. You're extremely interesting, and I really appreciate you coming here. And I want to say thank you to you.
Thank you so much.
And I hope that we managed to spark your curiosity too.
I'm sure you did.
You're welcome to follow us and join the conversation. We're on LinkedIn and YouTube. Just search for Llama Cyber. It's usually in Hebrew, but here we go. Llama Cyber, or Y Cyber, if I translate it. A big thank you to Michal, Bachar, and Assaf Lansky. Editing by Yellow Flamingo Studios. The original music is by Judith Teitelbaum. And of course, I would like to thank you. Thank you for listening. I'm Danit Leybovich-Shati, and I'll meet you in the next episode of Llama Cyber.